Dear students, hi, I am Murli, the facilitator for this lesson, Center of Gravity and Stability of Bodies. After completion of this lesson, you will be able to define center of gravity, explain the center of gravity of regular bodies, explain the center of gravity of a triangular lamina, explain the center of gravity of annular ring, and explain the center of gravity of an irregular lamina. Before entering into the lesson, let me ask you a question. Have you ever been to a circus? Yeah, that's right. You must have gone to circus several times. We all enjoy the things which we see in circus.
In circus, you see a man walking on the rope, a man balancing on a pole, bicycle balancing, an elephant balancing herself on a ball, a dog balances on a ball. And also you must have observed in playground, football players rotate football on their point fingers, and you must have played with stop.
You may be wondering that how all these are happening. In circus, man on the pole and a man on the rope do not fall. Elephant balances its weight on a ball, but it doesn't fall. In the same way, the ball doesn't slip from the point finger of the football player and the wooden top doesn't fall down till its speed is decreased. Do you know why all these are not falling down? Don't worry, you can understand the secret behind it by studying center of gravity.
Look at this example again. The person walking on a rope holds a long pole in his hand. He changes the orientation of the pole such that the line of action of his total weight always passes through the rope. So he does not fall down. To say clearly, every body is made up of a large number of particles. The man on the rope has different particles like legs, hands, trunk and head. While he is balancing on rope, his body becomes rigid. In a rigid body, the particles are held together in fixed position relative to one another. Observe the man on the rope carefully. His head, hands, trunk legs and feet are stiff. Each particle is attracted towards the center of the earth with a force equal to its weight. The man's all particles are fixed together and attracted towards the center of the earth.
Now, let's know about the center of gravity in detail. Center of gravity of a body is defined as a point of application of the resultant force due to the Earth's attraction on it.
Observe the example. A rounded plate is balanced on an arrow. F1, F2, F3, F4, F5 and F6 are the forces acting on the particles P, Q, R, S, T, U respectively. The resultant of all these forces is equal to their vector sum. Let's see another example. A scale-like rectangular shape is balanced on an arrow. F1, F2, F3, F4, F5 and F6 are the forces acting on the particles P, Q, R, S, T, U respectively. The resultant of all these forces is equal to their vector sum. In these two examples, the arrow showing the direction of this resultant force is called the line of action. This total force or weight of the body appears to act through a fixed point G irrespective of the position or orientation of the body. This point G is called the center of gravity of the body. The position of the center of gravity of a body may be falling inside or outside the material of the body.
So far, you understood what center of gravity is. Now, let's know about the center of gravity in different types of bodies. To know center of gravity in a regular body, let's do a scientific experiment.
Take a uniform meter scale. Indicate the beginning and ending of the scale as A and B. Note its midpoint as G. Indicate the adjacent points as P and Q. If you try to balance the scale on arrow at the points like P or Q, it does not remain horizontal. But if you suspended the scale at the midpoint G, it remains horizontal and stable. This geometric midpoint G is the center of gravity of the scale. For a body of uniform density and regular shape, the G coincides with the geometric center.
Now, let's know center of gravity in a triangular body. To know center of gravity in a triangular body, let's do a scientific experiment.
Take a cardboard sheet in triangular shape. Indicate the three corners as A, B and C. Note the midpoints of the sides as AB, BC and AC. Note the midpoint of sides AB as D. Note the midpoint of sides AC as F. And note the midpoint of the sides BC as E. Join the sides CD, AE and BF. These lines meet at a point G. This point G is the geometric midpoint of the triangular lamina. If you hang the lamina at the point G, it remains horizontal. If hung at another place, it does not remain horizontal. So, with this experiment, you can understand that G is the center of gravity of triangular lamina. To know center of gravity in a circular body, let's do a scientific experiment. Take a circle-shaped cardboard sheet. Put a thin wire on circle and name it as A and B. Fix the wire in that position to the ring with gum tape. Similarly, balance another thin wire and name it as C and D and fix the wire in that position to the ring with gum tape. The wires AB and CD intersect at the center G of the circular lamina. Suspend the lamina through the point G by a thread. The lamina remains horizontal. Therefore, the geometric center G is the center of gravity in circular bodies.
On observing all these examples, you can understand an important thing, that for all regular shape bodies, the geometric center is the center of gravity. So far, you have learnt about center of gravity in regular bodies. Now, let's know the center of gravity in irregular bodies. Before entering into this concept, you should know what are irregular bodies. Irregular bodies are that which are in improper shapes. They do not have any specific shape. See these examples. Let's do an experiment to know the center of gravity in irregular bodies.
Take a thick cardboard sheet of any irregular shape and make 3 holes A, B and C near its edge. Suspend the lamina through a hole A by means of a string to a nail P. Suspended a plumb line from the nail P. Draw the line AD along the plumb line. This is the line of action of the weight of the body in that position. Similarly, suspend the lamina through other holes B and C and draw the lines BE and CF along the plumb line. These straight lines, which are the lines of action, are vertical and they intersect at G, is the center of gravity of the irregular lamina.